really the upcoming missions. So naturally, you should be really looking for some of these things as we go along, making them to happen. And I would like to see at the end of it whether I can list out upcoming 10 missions in the next year, or upcoming 10 missions from now onwards, and then see how best we can cover the rest of the things as we go along in future. Probably one of those topics which I thought I should share with all the people in a popular lecture like this, because also then there's nothing like talking about one single satellite and telling all about the satellite. Instead of that, I'll just give you a bird's eye view of what all things that we are trying to do, and trying to really make an impression on how best Isro is working and how best Isro Satellite Center is working on some of these upcoming missions. So that's why it's called Upcoming Satellite Missions, wherein I'm just trying to give an overview of all the satellites, and then I'll see how best okay, I just given the factors like what is our Indian space program, just one slide is there, just to bring somebody with more up to date on these things. Then something on very brief introduction on what the satellites are, then all about the future satellite programs. We are making 4 different types of satellites, 5 different types of satellites, like the communication program that we have, the navigation program, that the other one that we have opened up recently, the remote sensing program, a very good one that certainly is there for everybody to look at that, space science program, and interplanetary missions. I just broken them into one space science program, what we are currently doing, and interplanetary missions that currently what Mars mission is trying to do. So these 5 divisions are there, and of course I just conclude only one user. Okay, what is our space program looking like? The photograph that we are seeing is Vikram Sarabhai and our father of Indian space program. And of course, he always told that India should not be competing with anybody else other than themselves, because all said and done, he believed that we can carry this technology to the common man through various applications. We don't have to compete with anybody else in the world, because all said and done, by the time India started, there was enough, what we call the Cold War between USSR, as well as USSR and America. But nothing of those should really matter for us. We just have to really see how best we can utilize the space program for our own development, and that's what he gave it as India's program should be utility-based and user-based rather than anything else. So accordingly, we just followed his advice, and of course we are just trying to talk to certain things which we have done later when we have really made our mark as one of these satellite service providers. But also then we are trying to talk to 5 different whatever divisions which I gave. So hopefully we will continue further and do some more missions which are only a small variation of whatever that's fundamentally there for us. So accordingly we have got many of those missions lined up, and then of course essentially we are having the space assets INSAT series, the remote sensing series, the navigation series, and our space science missions. Of course, we also have certain things which we do for the international cooperation, because as we go along, we need to make our own impact on the rest of the world. So accordingly, we have been able to really launch about 19 or 20 countries have got their first satellite through the Indian missions as one way of international cooperation. And also we have been able to take these services from our satellite to those countries also as another service that we have been able to extend. Of course, we are remaining the same human resource, not more than 16,500, because also for various reasons we are not got the right extra manpower than what we wanted. But with this manpower, we have been able to really run the show from different centers. And of course, this is one thing which is really nowadays it's appearing more in terms of money that we are spending. It's only about 7,300 crore rupees is what we are doing for per year. And This is considered as only $1 billion as 1/6 around that for the US NASA budget. But this is what we are currently spending with industry and academia interfaces, and of course we are nestled in the state-of-the-art technology as we go along. This is in short about what we are doing, and we have been able to really sustain this the entire organization through some of these features. We are not really doing much in terms of human resources also, because we have found that we've been able to manage with the available human resource or whatever the work that we have currently taken up. And coming straight away to the number of satellites that we are making, just to recap, of course we got the launch vehicle which is done from our Vikram Sarabhai Space Center, VSSC, and the Rocket Propulsion System Center and Satish Dhawan Space Center. Three major centers are there from where the launch vehicles are designed. That's what is currently the Polar Satellite Launch Vehicle and the Geosynchronous Satellite Launch Vehicle are the two main launch vehicles for the time being. And of course they are having quite a good amount of maturity. The one highlight for the information all of you are part of this thing. On January 5th, we launched the first cryogenic stage, Indian-made cryogenic stage was launched from Sriharikota, and that was a wonderful success for us. And with that, India made its mark as a new agency for developing cryo stages, and with that we have come to terms with rest of the world as far as geostationary survey is concerned. Of course, PSRV is certainly a very well proven launch vehicle. It has done about 26 continuously satellite launch vehicle missions. All different categories of different types of missions. I just explain as we go along. But certainly this has proved to be one of those very good workhorses for us as far as launch vehicles are concerned. And of course, the satellites already introduced to these satellites: remote sensing satellite, communication and meteorological satellite, navigation, space science and exploration satellite. Applications, of course, we have been able to really prove the applications part, how exactly we have been able to really put that into use, and what exactly we have been able to prove that India happens to be one of those major users of the space assets, is what I would like to say. So once the satellites are in orbit, it is not that match is over. We continue to use it for different applications, for different agencies are available. We have been able to really pilot some of those work that is really involved in terms of the usage. What we see here is some of the uses of the remote sensing satellites. As we go along, we'll see some more applications of different satellites. Now coming to this is just another glimpse of what exactly has been happening in terms of communication satellite, which all of you are generally familiar with, the broadcasting and rest of the things that go along with that. Then remote sensing satellites are used for different applications. Well, the improved position accuracy is one thing that's driving us, and navigation applications for different position determination in terms of aircraft or ships or vehicles. Scientific research for the application of atmospheric studies is one of those things. Aerospace studies is another thing. And of course, and many of these things are listed under the remote sensing satellites, where you can use it for a number of applications. All of them are listed here. I don't need to go through the details, but we've been able to prove that India happens to be one of those countries where all these applications are brought to use wherever possible. Most of these applications are started from Isro, different agencies, for example, Space Application Center and National Remote Sensing Center. They are the two application agencies, the centers wherein some of these concepts are proved, and we have opened up this for anybody else to really use it. We've been able to prove that how exactly one can use it. All these things have been piloted from different centers. Nowadays, we can certainly say that many of these things have found their place in the user department. Essentially, Isro happens to pilot some of these applications, but ultimately, user departments have to use, for example, forestry and some of these things have, the departments have themselves started. Similarly for the agriculture, we just made a forecast for the upcoming crop estimate, but that has now been taken over by the agriculture department, the government of India, and and that is going on now currently for the last 2-3 years from them itself. Similarly, for different applications, different users have been identified, and they go through their own planning commission's approach, and then finally they find their applications. So similarly for communication satellites, all these things have been really done, and all these things have really been done, and we got the applications quite well written now, and we really need to use it for corresponding users and the different headings, whatever that's given there. And they have been used for not only for regular use, but in disasters also. Whenever a disaster is there, being able to really come up with some of those applications, giving the communication itself for the different 2-3 points are there, and they can be connected to some of these terminals that we can be deployed with quite good ease is what I should say, and then that can give the connectivity through satellites. Some of these things are the very well known applications. And of course, further given in terms of education, how to connect different universities is very well understood, and what we started in training and development of communication channels. We have been able to pilot it further. We have been able to give the satellite projects to satellite different education systems, and we have been able to connect one good professor to the rest of the colleges in one of those applications that we have been registered. Telemedicine connected different hospitals or major hospitals to different small hospitals or in the rural areas if possible, and he completed the data sent through the satellite. He doesn't travel all the way, and based on the conditions of the patient, either one can advise the patients on wherever they are, and ultimately get the medical aid to them through the local people. In case required, only he has to travel, and finally find, if required, only the super specialty surgeon will be available in his hospital. But the first information can be directly transmitted to the super specialty hospital through the satellite network. So these are all things that are very well proven in different applications. People have been able to use it, and the result of the system is being now put to use, and many people are really benefited from some of these things. Of course, this is the latest thing on what Indian space program has done, especially the satellite launches have been listed out here. Basically, you can see here that number of satellites that we have been able to make in Isro Satellite Center, the center which I represent. We have done about 71 satellites, to be exactly the number given here, of which 2 spacecraft missions happen to be for somebody outside India. That's why they have been separately given. But 69 satellite missions have been done from Isro Satellite Center, and you can see here there's been a very big growth of what was happening here. Suddenly you can see that it's going on fairly, I should say, the rapid growth is there in terms of number of satellites that we have been able to really make. And that is more because now we have been more experienced in terms of making the satellite. We can visualize the systems that are really required for making PPA production. And also see that things are happening more frequently than what was happening earlier. So like for the last 2 years we've been able to launch 9 satellites into orbit. And this year 3 more satellites are lined up for launching. Before December itself we should launch 3 satellites. The first satellite should be available for use. All these things are really available for use in terms of their application, different applications where some of them are communications, and 2 remote sensing, 2 are navigation satellites of the 7 satellite constellation that I'm talking about, and of course many of them are remote, and other things are satellites from science missions, and especially Mars mission is one thing for which we are doing much more on how we are going to do the Mars mission as they come here September 24th, which happens to be the Mars insertion day. And this year, September 24th is the date that we have chosen. And on that day, we have necessarily make it become the satellite of Mars. Whatever that we are sent from Sriharikota, it went all the way and is going towards Mars at this point of time. I'll tell you more about that. So this is essentially what it tells me is we have been able to make a steady progress right from Aryabhata in 1975. We've been able to make a steady progress of different communication and remote sensing satellites have been there. And at some point in time, we thought, why don't we go for Chandrayaan-like mission, the moon mission is one thing that we chose in 2004-2005 time frame. Then we made a mission of from whatever resources that we get here. We said why don't we use it for making a satellite move, and we found that what finding was one of those things that happened in Chandrayaan-1. After that, of course, we have to go and gone ahead with making Chandrayaan-2 and all those things, which are upcoming things. And correspondingly, we have been able to really do something more on navigation satellites also. What it essentially tells you about whatever that we built over years, we've been able to really make it into production item in some of the satellites, some of them into the routine production, some of them are the real R&D, research and development work, and some of them are supposed to bring the technology also. All put together is a good technical work in terms of understanding, making the satellites is one part of it. Other one is how best we can certainly make the technology available for different user applications, which is the one which really does Isro's point towards saying that we can use some of these satellites for day-to-day use. That's exactly what I'm trying to impress upon. Now, just to, for some of the people who are not here, what is a satellite is what they put there. Essentially, any satellite, a satellite is basically an object that revolves around a planet in circular orbit. But this is only how exactly the what we meant by satellite, artificial satellite is what I talked about. Natural satellites are also there in terms of moon for Earth, and artificial satellite what we have been able to do on ground. And of course, what is in orbit is the other question which is normally asked. Imagining part of the satellite, because nothing like orbit is given in some form. The way if you write the orbit, actually it's the imaginary part of the satellite and part in orbit. In the orbit, the farthest point in Earth is 14 years per velocity. That's one thing. Velocity is the other one which is to be given to the satellite. With that velocity, it will continue to be in the orbit. That's why it keeps going. Because once you say the satellite is in orbit, you mean the velocity actually is is greater than 7.8 km per second. That's the velocity given by the launch vehicle. And of course, between 7.8 and 11.2, so long as different orbits are there, you can certainly have an orbit for different applications. And so once it crosses 11.2 km per second, which is what happened for Mars orbiter that I'm talking about, we can beyond 11.8 km per second, and we left the Earth orbit, and now it's going towards Mars. This is one of those things which is giving some idea of what the satellite is and what are different types of satellites. What is satellite itself is one thing that generally asked question is. Essentially, everything in one view we have here. We just tell that look here, the satellite is only one entire closed body, maybe a cuboid, what I can simply tell. So that one, because that is the definition for this. It looks like that is the definition for layman. And what I am trying to tell is, it has two components. One is called the mainframe systems, and the other one is the payload. Mainframe is the one which is consisting of structural elements, the structure that is really required for housings and this different equipment. Then, of course, it needs a power system, it needs a thermal system, it needs telemetry, command and tracking network, both the based on RS systems, mechanism system for different deployments that we have to happen in the satellite. Then an accurate control system, basically consists of control electronics, sensors, actuators, propulsion systems, least trackers, and the entire control system, which is driven by software. All they put together for the mainframe system. And the payloads could be whatever the configuration that we say telling in terms of communication payload, or in terms of navigation payload, remote sensing payload, space science and internet. These are all things that different types of payloads are there. Depending upon the mission, one can choose whichever is the payload that can go along with that. So mainframe systems and the payload together is from one single system. That is where the entire challenge is there for building the satellite. All these things one has to plan separately for structures, thermal mechanism, everything together, not necessarily integrated into a single satellite. Corresponding payload also has to be brought, everything has to be brought into a single cuboid, for example. That's what Henry said. That's always that's the easiest way to make a satellite is involved. So that's what put together. Payload systems have to be tested separately. Maintenance system, each one has to be separately tested. Ultimately, all of them together has to be integrated and tested. Assembly integration testing has to happen, along with the quality assurance team, which is the one which really tests that whether the satellite is spaceworthy or not. What are the different conditions that are set for government, for different subsystems, for different applications and different, what I should say, the temperature and the vacuum conditions in space, of course. Vacuum is hardly anything, -10 to -5 are slightly lower than that. And of course, the temperatures have to be between -100 to +50 or +60 degrees centigrade. One has to really qualify the system for slightly more than these applications. All these things are part of the AIT activities. Individual subsystems also will go through all these things, and ultimately all of them put together become a satellite, and the mission operations along with the rest of the things will go on for us to really say that everything will be done correctly. This is only very, very rough sketch of what we are trying to talk. Each one has its own detailing part is there. Each one has its own specialization. Each one has a different way of doing that. That's really not really the topic that I have taken today. So please understand that maintenance systems and the payload systems together on one satellite, and that's the one which really gets into orbit, and that's the one which you use it for different applications. So now whatever that I told in terms of the entire thing together is what I'm trying to show here. This is one of those satellites in terms of satellite in terms of what the configuration could be. So two satellites are shown here. Essentially, you should understand that these are all the different equipment panels that are there, and your two solar arrays are there, the batteries are there, and all these things together will form only one satellite. And that is what I would like to impress upon, that all things put together will become a satellite like this. Many things are folded when it's launched, and after it gets launched, we need to make effort from the ground to deploy some of these things in orbit, and then say that these things get into the configuration that we require. This is just to tell that typically satellite consists of so many elements which are made and form an envelope like this. This is a satellite ultimately that's get launched by setting it on the fairings, and then it gets into orbit. And then after it gets into orbit, at a suitable time, we deploy all these things in orbit and make sure that that's the one that becomes satellite by itself. So this is one of those typical satellite configuration I'm trying to show. Now coming to the future communication satellite, future satellites program that we develop on first the communication program, then the rest of things will follow. Essentially, what I'm talking about is a communication satellite. Essentially, we have about 12 satellites in orbit already available for us, but each one has its own lifetime for us to really follow. It's not that one satellite is there for years and years. Its time is limited. It could be 8 years or 10 years or 12 years. Today we are talking of satellites which are about, about 10 to 12 years is what we are talking about. But we are now, what we have taken now, the upcoming satellite missions, is that we have said that it should be 15 years lifetime is what we have said, because many things can be done on ground. We can make it more robust, and also use the correct components in the satellite, and we can make it really available for 15 years of life. Let's say if we launch it today, next 15 years we don't have to worry too much about how the next satellite should come. We have enough time to prepare for next satellite and all that. So what I'm trying to tell is, this at 15 is the upcoming satellite. Next year it should be launched. We are putting our efforts to make it into a good satellite of fleet and sorry. From Arianespace, the European launch vehicle, and then we have an SLC that we get into orbit properly as for this one. And of course, Europeans have been able to prove their launch vehicle many times. They have been able to prove that. We can go with that. We can go with this launcher. So Ariane 5 is a launcher for this, and we have been able to really get things done correctly. Then next one will be the discussion. Let me see how best we can record this. Next one, of course, is research. That is always done in our center.
Just like incubating them.
I agree with you, but it's difficult for Isro-like agency to really sustain for because once in a year it's available. Yes, that's certainly available for them to really showcase their talents and all that. But if somebody wants to really sustain it and give it as a day-to-day affair, that needs to be done by somebody else, really. But we have been able to do it once in a year. Yes, we are doing that. Thank you. Yeah, just go ahead quickly with. Okay, these are 16 one thing which I was telling. This is, of course, is ready. December 3rd should be launched from French Guiana, for which we have the contract. Everything is ready for us to go. But this is one of those satellites which got. It generates about 6.5 kilowatts power. It's a nominal thing for the satellite of this class, 3.5 tons class, and it's about 48 transponders are there on this, and we can certainly use it for augmentation of number of transponders with the country. Similarly, these are $9 satellite. This meant only for to go on GSLV Mark II. That's the launch vehicle that's approved now. It's only 2.1 tons is the one that's there, and it can give about 12 payment transponders. But of course, we have put in this case the chemical propulsion is nominal thing that's unavailable, but we have put the electrical propulsion also in this one, and just to say how exactly electrical propulsion will behave in orbit, and that's what we are trying to prove on this specific platform. But it's going to be launched from Sriharikota in third flight of GSLV Mark II. First, the next one is GSLV. These are 6 is the one that is going to be launched. I'll come to that. And DSAT 11 is really something different for us. This is one thing which we have really taken up as a very big development. As I was studying all along, I1K is the 1 ton class, I2K is a 2 ton class, I3K is 3 ton class. But this has made a bigger difference for all of us. We think that we can make we have to make certainly a bigger difference for our communication arena. We said that we stay to up to 6,000 kilograms satellite is what we talked about. I6K is what I'm telling here. It's about 14 kilowatts of power. You can see the 6.5 kilowatts are big kilowatts is what we are currently handling. It's taking about 14 kilowatts and slightly more than that. So naturally, this is going to be certainly a bigger difference for us as far as the upcoming operations are concerned, and in-orbit operations is also equally challenging. All put together, it's going to be one of those newer satellites that we are going to make. That's why it's called. These are 11 is what we are called, and we are into the qualification model at this point of time at Isro Satellite Center, and this should become a flight model and it should go on some other launch vehicle, not necessarily Indian launch vehicle. But certainly it's going to become one of those big satellites for us. 6 ton satellite is what we are talking about. Application, of course, are high power, high beam satellite. This is the current thing is high power, multi beam, and the new architecture for community with VSAT plus is what we are talking about. Similarly, this is a replacement satellite for us. This is also getting developed at Satellite Center. These are standard 3 ton class satellite, which also have to be launched probably from immediate requirement is from Ariane again, or some other equivalent launcher is what we want. That is 17, 18 are almost identical, except that as you can see here, one is having 24 normal C-band, and all these 6 are different frequencies are there and can be used. But this at 18 is some other set of satellite. Configuration-wise, they are almost identical as far as the mainframe systems are concerned, but for the payload is totally different. It's 48 transponders are there in this specific satellite, and we can certainly use them for applications in future. For different transponder replacement is one thing that I'm talking about. And similarly, in case of The search and rescue is one thing that I was talking about as a possible transponder and possible support for some of these disaster missions. So what happens is during search and rescue, once an aircraft gets into any problem, it's immediately its beacon comes on, and we can certainly pick up the signal quickly and transmit that information to a rescue coordination center and get the search and rescue operations supported from those agencies. It is possible to do that. This is what we have been maintaining this satellite disaster management support on a regular basis. And these are 19 and 20 other things that we are talking about. These are 19 happens to be is meant for our own use. So that's why, even though it's a 6-ton class satellite, this is what I'm talking about. But they've been tuned out to about 3.5 kilowatts because we don't want to put everything in this one, because this is going to go on our own development flight of GSLV Mark III. And actually, we have already tuned down this one just to give you satellite for this. Resembles a 6-ton class satellite as well as configuration is concerned, but it will not carry so many transponders. It's only about 5-6 transponders are carrying. But it's more to say that with this, our GSLV Mark III will be able to really send the satellite off the 6-ton class satellite, but in a reduced manner as far as Mark III is concerned, GSLV Mark III is concerned. But we are going to have a full 6-ton class satellite. This 20 is what we are calling about. That will have 35 spot beams and about 7.8 kilowatts is what is good enough for us to really support this satellite. This is what another one that's really taken up in our Center for Development. And of course, this is another one which is very useful for us. This one which can be fitted into any of these concepts. You have to have 2-ton class satellite. We are able to really put this satellite available as a return data relay satellite is what we want, because in the geostation it's arbitrarily remaining, and the ground systems can talk to the geospatial satellite and bring the data to the different ground stations. This is one thing that we want to try it out in the upcoming missions. This already formed a team for doing all this in the IDRSS class, and that shall cater for low data rate from the remote sensing satellites to the communication satellite is possible, or medium data rate for manned mission. For example, if you are taking a manned mission, it is possible. Or high data rate also is possible from this, and we can use it for data relay satellite from any other configuration that we want. Basically, 2 satellites should be good enough for us to really get the data from this part of the globe. So we will really manage these 2 satellites and bring the data for different applications as far as different missions are concerned. We will do that. Now, in the navigation satellite scenario, things are different. This is how we are talking about the regional navigation satellite system. It is a 7 satellite system is what we are talking about. A unique configuration of 3 geostationary orbit and 4 geosynchronous orbit constellation is what we are talking. It is self-reliant system. It is not dependent on GPS or anybody else. GPS equivalent is what we always tell. And what we are trying to do is you send the satellite between 34 degrees to 150 degrees. That is the spread within which we position these satellites, and about then dual frequency downlinks are used, and we can get a good application for aircraft, ships, vehicle, fleet movement. All these things can be got from these satellites. So what I'm showing here is these are the 3 geostationary locations, and these are the 2 geosynchronous locations. So with these 7 satellites, we can cover the entire Indian region, plus something more as far as the applications of Navy is concerned. So we have been able to bring in these 7 satellites and to meet this position accuracy. We have brought up 2 satellites already in orbit at this point in time. First was launched on July 1st of last year. The second one was launched in this year, April 4th. We launched IR-1A and 1B. They are in this orbit. 2 of them are really going in this direction. Now the next one is ready to go to 83 degrees east. Then of course the 34 degrees east is 1B. And these 6 together should form the constellation for 7 satellites. With these 7 satellites, we have suddenly the good position accuracy and position is determined properly. And aircraft, ships, everybody can get the information quite well in advance. We are quite well as and when they go in any of these in these parts. Basically, Indian part is what we are talking about. So they'll get information about all those movements, but at the same time they'll be able to really get this information from different ground systems. We've got all these ground systems deployed as far as these satellites are concerned. With 2 satellites in orbit, we have planned the 3rd and 4th this year. One is on September 19th, we got one date given. That is for the 3rd satellite. 4th satellite will go into this orbit sometime in December. So with these 4 satellites, we should be able to reprove the concept more in a much better way, and we will complete the constellation by the middle of next year. There are 3 more satellites, IRNSS, 1E, 1F, and 1G. With those 7 satellites, India would have got its own regional navigation satellite system. This is how the whole concept is. This will just tell you what the satellite looks like. This is another just picture of those satellites I was looking at. Essentially, we are talking of a satellite in the orbit. This is certainly going to be a simple satellite of 1,400 kilograms. This is exactly the missing. It gives about 10 years is what the time that we have put for this. It's done with very compacted utilize in one-ton class satellite mission. 1.4 tons is what we are sending into orbit, and a good amount of power is available for us to really operate those clocks and all that. With this, we are being able to get the right information. 2 satellites are doing very well in orbit. We have been continuously tracking it from both Hassan and from the navigation center in Bangalore, and we are being able to regulate all the functions of both payload and the rest of the orbital elements. Everything is being done, has been done quite well. And this marvel, which is already available now for navigation, basically, this is GPS itself is taken as reference, because GPS already there, constellation, everything is available. For Indian use, we're being able to really use this as a region of interest. We're being able to correct the ionosphere and troposphere signals are corrected from GPS signals. They are corrected from ground and then up into the satellite here, DSAT 8 and DSAT 10. They're already in orbit. With these 2 satellites, we have been able to get these services to the aircraft or to see if any of these things are possible. We've been able to really demonstrate these applications are quite well received, and we have got the control center and also the land use center is available in Bangalore, and we have put another control center near Delhi. So all these things are working quite well as far as the government system is concerned. But this is, of course, please note that this is dependent upon GPS signals that are available from American satellite, is one part of it. Other one is, of course, it's not a regional satellite to what we are looking for. This is somewhat in the global way we are looking at. So when the IRS satellites are available, there is business services for our node applications, and we should certainly use them to complement and supplement the use of data. And the remote sensing satellite program is fairly clear. We started from 1 kilometer is what we started off with very early satellites. Now we are having a satellite with about 80 centimeters with the resolution of the picture that we can get from the Cartosat series. But we have broken them into land series or in the both in terms of applications or in terms of stereo capability. All these things we have been able to get climate and weather information. We have been able to ocean application, national surveys, natural resources mapping, detailed planning. All these things have been supported by different satellites in orbit. Being able to really make 10 satellites all in orbit at this point of time. All these things are working quite well, and they are being used for different applications depending upon the imaging capability that we have built in. It can be, some of them could be higher swath widths, some of them can be narrow swath widths but different, like higher resolution. All these things put together, being able to really make good use of these satellites for our own use. And recently we got this. Possible is meaning but make best use of it for various applications. So with this constellation available, then nothing much to really look forward to in terms of applications. But as we go along, we find that there are fine. So what we have found is not that the applications are not sufficient for us to really stop working for these things. So we said that we have to really move in terms of resolutions and also in terms of different applications. So what we are trying to do is whatever 80 meters resolution pictures that we have got in Cartosat series has to be improved to 60 centimeters resolution. And that is further to be improved 25 centimeters is what we have put the goal. So naturally we have to do more work in terms of achieving some of these things in the Cartosat 2C and Cartosat 3 series. So that's what we are trying to do as far as abbreviations are concerned. So I'm just listing out some of those things. See, Isrosat 2A is upcoming satellite in the next year later is what we are talking about. Isrosat 2A is a continuation of whatever that we have done for IRS 1C, 1D and Isrosat 2 series. Now Isrosat 2A is coming up. It's almost identical to whatever that we have flown, except for small changes. So this is going to be one of those workhorses for us, Isrosat 2A. OceanSat 3, similar to OceanSat 1 and OceanSat 2 are available. We are making OceanSat 3, but of course here the small changes are done with respect to the bands that we have for the ocean color monitor, and the K band spectrometer has to continue for us because that's one thing which is proved to be good. And of course this is another new thing that we are adding, sea surface temperature monitor. Again another sensor which will be able to indicate the sea surface temperature for us to read how the ocean currents are moving. These three sensors together will become the component for OceanSat 3 applications in ocean geography, and this is going to be available over time. And of course, the other one is a good turnaround. We are just making another satellite for us, which is called StatSat 1, which has to go immediately because we went through a small problem on the OceanSat 2 itself, where we lost a microwave sensor because of different problems that we encountered there. But we are working on this feverishly to say that on this one only one sensor is put here, a 720 kilometer altitude, 360 kilogram satellite with all ocean only spectrometer, which is useful for learning all about the ocean currents and all that. That's now coming up. This should get into orbit sometime in 2015, middle of 2015. And Cartosat 2C is another one which is really getting ready in our center. This will happen as we go in upcoming next October to December, what we are talking about, into a 500 kilometer orbit. This is going to be another change in, big change in resolution, because whatever that we talked about 80 centimeters, it becomes 60 centimeters in this satellite. This is not further fall on to F. They come in every 6 to 8 months time. Each one will follow. But Cartosat 2C is the first one. It gets 500 kilometer orbit, and this we can certainly put for better applications than what we have been doing. And Cartosat 3 is one thing which we are talking, because this is another upcoming satellite which is getting into us. You can see here 450 kilometer orbit. This is certainly going to be very high resolution satellite. It's going to be nearly about 1500 kilograms. It's certainly going to be a bigger satellite, 1500 kilograms. Power of 2000 watts is what we are talking about. A small satellite of this type, we want to get advanced high resolution spectrometric and multispectral camera. Both are put here. And of course, nurturing the hyperspectral imager we also put here. It's very, very complicated satellite is what I should say. Both PAN and MX are put in a small satellite, and we are necessarily make it pan resolution of 25 centimeters is what we are talking about, and multi-factor is about 2 meters. So it's going to be one of those very state-of-the-art satellites that we are currently envisaging. A lot of work is going on in terms of design and development of this satellite bus. RSI-3 is another one which is going to be here, because that's going to be almost similar to what we have been doing in terms of RSI-1. This is supposed to take care of replacing the microwave remote sensing satellite. So we will get in the 536 kilometer orbit with such a big power is what we are talking about, because it's going to be really synthetic radar is there, and the applications of this is different microwave imaging of natural resources, and some of these things are already operational now, but just continue the operations as far as we are concerned. Then GISAT is another one, which is geostationary satellite. We have to necessarily make it into a small satellite is good enough for us to really do this. We need to really put a multi-spectral image. Only thing is that we have to do is it should certainly get into the geostationary orbit is what we are talking, and it should certainly be able to really support a 50-meter resolution from the geostationary orbit continuously available for us. In fact, TDR and 3DS is another new set of satellite coming up. TDR is one which is being made along with TDS. This is of course going to be 2.2 ton plus satellite, whatever that we have launched in our GSAT 14 like satellite from GSLV. Similar thing will be done for this also. So we are talking about 2.2 ton class with 6-channel imager and internal sounder. This is identical to whatever that will be there, except for small improvements as a day. Otherwise, this will certainly follow the meteorological satellites currently already in orbit. TDS will further augment our meteorological applications. ISAT is another one which is to provide global coverage of repetitive basis. Is another thing we can, but only thing that we have been able to really get to the wavelengths of such a large wavelength, 450 nanometers to 2004 nanometers. It's a continuous 10 nanometer strip width is what we are talking about, and resolution about 30 meters. This is fairly complicated satellite, but we have to necessarily do this because in one single satellite we should be able to get different spectrometers available both in very near infrared and the short-wave infrared region is covered. 600 kilometers satellite into this. We have put all our team into place to really get this 30-meter resolution, and is going on at our center. The other major project that we have taken up along with Jet Propulsion Laboratory USA, we are working on this on a continuous basis. But of course, this is not driven by the schedules of both NASA and Isro. It's not like a normal satellite, but I thought to just highlight here saying that what we are trying to do is to give the mainframe system from ISAC and space applications will bring the L-band synthetic by the data, but the big thing has to come from JPL for new synthetic by the data, both in terms of technology that is there in terms of the scanning part of it, and also the new type of antenna, which is about 12 meter antenna, is what we are trying to see. This is the antenna part of it, and this is satellite. This has to be gone from GSLV, what we want sometime in 1920. But the work is going on continuously on this. Both NASA and Isro are both keen on doing this, but it takes a lot of time. It's what everybody's knowledge is. We are also continuing with our work as far as we are concerned, as far as satellite building is concerned. Here's another new thing that is there, because similar thing has been done for different satellites. But this one is more to say that we want to bring the docking is another one which is to be done in orbit. Basically, two satellites are not from the same launch vehicle or from different launch vehicles, but we are constantly bring them together, make a single satellite and make a mission out of it. What we are trying to say is the technology demonstration of window and docking is what we are talking, using two IMS buses, two small satellites is what we are talking, 150 kilogram, and then they can go on a single satellite PSLV flight and get into orbit. Then we can demonstrate the controllability and target of from AOC from the control system of chaser spacecraft with the condition, showing the possibility of extending the target. But two things are there. One is making a single satellite out of two satellites, one aspect. Another one is after docking, you can make some more missions out of it. Or even if they are separated out, it is also possible in orbit. You can make two missions out of it. Is another possibility. This one is also study is already commenced. We want to really get the satellite ready sometime 2 years from now is what we are talking about. Now, space science programs is another thing which is important for this. Has been is even last year also I showed this because this we are not been able to really, get going still. But this year, of course, things are looking much different. All for the 5 payloads which are planned for the AstroSat, 4 of them are being doing now. 5th one is coming sometime in September. We should be able to really integrate them together, make a mission out of different spectral bands, right from UV to hard X-rays is what we are talking about. So different experiments are planned in different frequency bands. This is going to be one of those good satellites from Isro, 1,500 kg satellite. It should get into orbit sometime middle of next year is what we are thinking. Hopefully it will be it's possible to really generate such a mission out from this thing. Our science objectives are fairly clear. What are things that one will do with and all these things are really some of those really highly scientific satellites what we are talking. But we are supporting different satellites experiments to be built and also different subsystems for the satellite to be built. Again, another one which is an upcoming satellite is of course going to be already getting into the payload realization phase at this point of time, and of course it's fairly easy for us to deal with the rest of the platform system, but unless we finish AstroSat, we don't want to get into this further. But enough science objectives are put and all these identified experiments are available for this, for which different developments are going on at different centers. Now coming to the interplanetary mission, is what Mars orbital mission. I just want to spend some time on this. This is one of those satellites which we built in about 15 months' time. Last year we were still building the satellite, I should say, at this point of time, and finally went into the right orbit through PSLV launch on November 5th. And then of course it went through different orbit maneuvers and then went into the orbit of on December. First we allowed it to really go towards Mars, and ultimately it's going towards Mars at this point in time. Our 75% of the journey is also completed now. September 24th happens to be the date on which we are necessarily from satellite for becoming a satellite of Mars, for which all efforts, all thinking is already done now. We are going to the final reviews for what we should be doing on September 24th. And once we are through with all these things, this should become a satellite of Mars. Afterwards, we will operate continuously this photometer, methane sensor, this exospheric expert and color cameras and clear spectrum. These 5 experiments are there on this. Only once we get into the orbit of Mars, we will operate for about 6 months' time, data as much data as possible. The very fact that we could do all these things correctly up to this point of time, and to say that Isro could build a satellite of about 1350 kilograms, and also to maneuver it to on the right track and going up to this point of time itself is a good achievement for us, and we are pretty confident that this should certainly become a satellite of Mars on September 24th. That's the big effort as far as the Mars mission is concerned. Of course, along with Chandrayaan 2 is what we are talking about. This is another thing which is happening. We should be able to really get into the orbit sometime in 2017 is what we are talking about. But everything is Indian about this thing. The orbiter is what we flew in the earlier mission, is the orbiter part. Then the lander and the rover part is part of the lander, and the rover is shown here separately. And these things have to go together, enter Mars, moon orbit, and then at some point of time, and this only lander gets separated from the orbiter, and then it will have a slow descent onto the moon's orbit, and then we slowly but surely put it on moon, and then we release this rover and perform experiment both lander and rover along with orbiter in orbit about 100 kilometers above moon surface. And with that we should be able to do many of these experiments that are listed here. All together, one single package of about 3200 kilograms is what we are talking about. And that is the liftoff mass for this entire system, for which we should use the DSLV Mark II is what we are planning to use. With that, we should be able to make a mission out of it, and if possible is what we have established that it is possible, and we are going to handle vessel planning that is required for making this one of those unique missions where India's orbiter, India's lander, and India's rover should go together, and these two should get separated out and land on moon surface, then perform the experiment. This is what we are talking in brief about Chandrayaan 2. To conclude, a lot of things are there for us to do these things. There are mind-boggling technological innovations which can bring drastic changes to the life of common man, is what we have understood, because many of these things are really supporting the life of common man. We need to bring the superpower technology to improve the life of everyone in our country. Each one of us need to strive to bring this change to make it better in India. Isro in large and ISAC in particular, we do everything that's required to meet expectations of the country. This is what I concluded, saying that we'll do our best and keep the flight of the flight night.